Okay, so on the right side, I'm asking you, okay, so if I just had a cosine of theta is equal to 0, I'm going to ask you for what angle would cosine be equal to 0? Okay, so you said there's two places where cosine is equal to 0, so I have my unit circle. I have two places where the x value of my coordinates on my unit circle are 0. It's going to be here and here. Pi over 2 and 3 pi over 2. Okay, so then you would say, okay, well, theta equals pi over 2 and 3 pi over 2. But that's not really our case, right? Because it's not just theta, we have 2 theta. So coming back to the left side, we say, okay, well, there's two places where cosines equals 0, but these aren't actually our angles. So I have 2 theta is equal to pi over 2, and I have 2 theta is equal to 3 pi over 2. So if you divide both sides by 0, one of your angles you find is pi over 4. Divide both sides by 2. The other angle you get is 3 pi over 4. And let's just double check. Do we need to add the plus 2 pi n? Bum, bum, bum. Ah, yes, because I didn't specify the interval, you have to assume it's for all solutions. So our solution,
So you won't always solve for all solutions.
Right. Unless I say over the interval, you have to assume it's for all solutions. If I just say solve, you have to write it. So angle is pi over 4 plus 2 pi n, and 3 pi over 4 plus 2 pi n. Beautiful, beautiful, beautiful. All right, let's think. If you have any questions, now is a great time to ask. While I wait for everyone to finish writing. Solid. We just have a one-page front back left, right? Nice. All right. Yes.
If you know negative cosine 2 pi over 2, then you would want
Negative cosine.
2 pi over 2, then you would want to move the negative.
Negative cosine 2 pi over 2.
Oh, sorry, 2 theta.
Okay. Equals what?
0.
Okay.
You would want to move the negative and over 2, which is 0.
Yeah. So if you multiply by negative 2 on both sides, the negatives will cancel out here, and then the 2's go away, and 0 times negative 2 is 0.
So you always want to have cosine.
Because you want to get it by itself. Because you don't want a coefficient, you don't want a negative in front of it. All right. Think I see people's pencils done. Okay. So we've dealt with double angles. What about half angles? Oh my gosh. So fun. Okay. So honestly, the half angle identities, you use it for specific angles. Use for specific angles. So what are the angles we would use it for? Well, I know 45 over 2, that would be a solid one, 22.5 degrees. So if I ask you, what is tangent of 22.5? Like, what the heck? That's not one of the angles I made you memorize. 0, 30, 45, 60, 90, and multiples. This is not 0, 30, 60, 45, 90. But what it is it's half of an angle you do know. So you could use the half angle identity. Because saying 22.5 is the same thing as saying 45 over 2. Question?
Yeah, why, like, for example, if sine is 22.5,
Yep.
the answer is pi over 8?
Nope. So pi over 8 would be, that would be the radian measure, 22.5 degrees. That's not what actually it would be, the answer would be. So taking sine of 22.5, same thing as taking sine of pi over 8 radians. It's not the actual answer. Okay, so here, let's go through example. I think it's better when you talk about it that way. So find the exact value of 22.5, of sine of 22.5 degrees. Okay, so here, this angle is literally going to be 22.5 degrees is the same thing as 45 degrees over 2. So if you look at the equation up here, you see it's in terms of theta over 2. So the theta I'm going to be plugging into the equation right here would be the 45. So I can rewrite 22.5 as sine of 45 over 2. And notice it's theta over 2 in the equation. So when I say 45 over 2, the 45 is the angle I'm going to be plugging into the identity. This is a point of confusion last year. I want to make sure we understand it this year. Yeah. Okay. Cool. Okay, so let's go and let's find this. So sine of 22.5 degrees. This is the same thing as taking sine of 45 degrees over 2. And then I could just plug in right here. Just use this equation. So plus or minus square root of 1 minus cosine. What's the angle I'm plugging in again? 45 degrees. Beautiful. All over 2 square root. Okay, so it says plus or minus. How do we figure out whether we're working with the plus or minus? All students take calculus. Which quadrant are we in? 45 degrees is in the first quadrant. Okay, cool. So since theta is in quad 1, we're going to use the plus. All right, so we're using the plus because we're in quadrant 1. So you use the actual angle, not the half angle, the actual angle to figure out whether it's plus or minus. Awesome. Okay. Okay, so let's plug in. Do we know what cosine of 45 degrees is? Root 2 over 2. Awesome. So the trig and pre-cal part is done. Now it's just algebra 2 simplifying under radical. 1 minus root 2 over 2 all over 2. How can I combine the top of my fraction? I have 1 minus root 2 over 2, and then everything's over 2. I need to figure out the big numerator. So when I say big numerator, I'm talking about this portion. Let's get this portion figured out so it's not a fraction in a fraction. Okay, so how can I, let me just pick one person. Here we go. Robert, how can I make a common denominator on top? Beautiful, that's all I wanted. Yep. All right, let's rewrite this. So I have 2 minus root 2 all over 2, and then it's all over 2 as the big part of my fraction. So I did 2 steps in 1. Oh my gosh, so much. So this is 2 over 2, so I have 2 minus root 2 all over my common denominator of 2. And don't forget, we got the big fraction bar all over 2.
Is the times 2 eventually applies to the whole numerator?
Which one? It just applies to the 1. Just to the 1. All right. So now that we have this, I want to deal with here. Dividing by 2 is the same as multiplying by the reciprocal, which is 1/2. So I have 2 minus root 2 all over 2. Instead of dividing by 2, I'm going to multiply by the reciprocal, which is 1/2. Oops, I ran out of room. Come down here. So I have 2 minus root 2 all over 4. Exactly. So I'm going to show like one extra step to make sure we see what happens. So notice the 2 on bottom is not in the radical, and this is the answer. This is the answer. Okay. Yep.
Can you rewrite that
As
2 minus 4
no, you can't, because this is it's like you have parentheses around here because it's a binomial. You're taking 2 minus root 2. You can't distribute the half throughout.
What do you mean?
So the root is the same as 1/2 exponent to the 1/2. It was a good question. Got the exact same question last class. Yeah. Thinking with your noggin. All right. Do we have other questions? You have a root inside a root. And you'll have a question just like this on your test. It is what it is. Yes?
If it was inside of the root, 2 minus rad 4, would you take
2 minus rad 4?
Yeah.
Well, you could simplify rad
Right, so
4.
then you would, gotcha.
There's
Yeah.
gonna be
If it was like 2 minus rad 5, all under a root, you have to leave it that way.
Okay.
Yeah.
There's
This is
gonna
the-
be a question.
Yeah.
Where's the root and root? Or like,
Yep.
yeah.
Yeah. Whenever you do a half angle, you're going to have a root within a root.
Always? Cool.
Well, whenever you use this half angle, yeah, because the only two angles I can really ask are 45 degrees and like 30. I mean, I could ask you 60. I mean, do you need more time to write this down? Let's see, where's my half angle? Number 9, sine of 67.5. What is 67.5 times 2? 135? $135, which is a multiple of 45. So number 9 on your practice test is a half angle. Wait, 135, what's the reference angle? Oh, 45, once again. It just changes the SIG and the plus minus inside. Okay. All right, let's keep going. Yeah.
So what do we do? That one, do we plug in like the 135 or do we plug in?
You would plug in, well, you could plug in 135, and then when you figure out what the answer for cosine 135 is, it's root 2 over 2, except it's going to be negative. So then inside, you see how we had a negative here? It would turn in, make it a positive if we're doing 135 there. Okay, but we'll go over this in class. All right, here we go. Solve. Sine squared x over 2 equals cosine squared x over 2 on the interval 0 to 2 pi. Okay, so let's see. This is the same thing as saying, right, sine of x over 2. Oh my god, why is my pen just not working? Ugh. If I take sine of x over 2, this is the same thing as saying, okay, well, I'm going to square that. All right, because remember, if I have sine squared x, it's the same thing as sine of x squared. I'm just rewriting this. And if I have cosine squared of x over 2, I can just rewrite this as cosine of x over 2 squared. And wait, if I have sine of an angle divided by 2, that's literally a half angle. So I can use the half angle identity? Yeah. Okay, let's do that. Sine of, no, nah. I mean, you could square root both sides, but then, okay, cool. So I have plus or minus sine x over 2 equals plus or minus cosine x over 2. Like, that makes it more complicated. But since this literally is in the form of sine of an angle over 2, which is a half angle, I'm going to plug into my half angle identity. Question?
Why can't we use the power to square?
You could if you want, but I'm showing you an example with half angle. So if you use the power reduction identity, you'll get 1 minus cosine x over 2. You get the exact same answer. Yeah, you get the exact same answer, actually. Did you already do it? Yeah. But showing you a second way to solve it. So let me plug in with the half angle identity that's at the top. So sine of theta over 2 is going to be plus or minus square root of 1 minus cosine of my angle, which is x, all over 2. And don't forget that this is squared. And that's going to be equal to, let's see, if I use the cosine half angle identity, I have plus or minus square root of 1 plus cosine of my angle all over 2. And this is squared as well. The square and the square root cancel out. The square and the square root cancel out. Because if you think, I have said I have a bad habit of just switching halfway through.
But we don't point to
No. What I care about is the process. Because it has nothing to do with like knowing how to do it. It's just like me being careless, trying to think about multiple things at once. So cross out the square. Square and a square root cancel out. If I take a square root of something, then I square it, I just end up with the same thing that's under the radical. And guess what? The plus and minus cancels out, because if you have a minus answer, what's that minus squared? Turns it positive. Is that your question?
Yeah.
All right. So rewriting this, I have 1 minus cosine x over 2 is equal to 1 plus cosine x over 2. Because if I take the negative root, then I square it, oh, it just turns positive again. That's why. All right, multiply by 2 on both sides.
So are there going to be a case when you're going to have a
Negative,
in front of the square root?
yeah. Up here, if I wasn't in the first quadrant, if I was in a different quadrant. If I was doing, if my angle was not in quadrant 1, if it was in quadrant 3, then it would have been negative at the end. So that's how we knew what to use. Here, the plus minus cancels out because we have a square. Okay, so I have 1 minus cosine x equals 1 plus cosine x. Subtract 1 on both sides, those just go away. Negative cosine x equals cosine x. I'll add cosine x on both sides. So I have 0 equals 2 cosine x. I want to get cosine by itself. Divide by 2. 0 equals cosine x. Oh, where did a problem like this? Where is, for what angle is cosine going to be 0? Exactly.
You don't.
Don't add plus 2 pi n because it's only on the interval. Yes.
For the multiplying, if we were to cross multiply, and
You would get the same answer.
yeah, but is it okay if we do it otherwise?
Sure. Yeah, so what she was asking about is cross multiplying at this portion right here. So you would have gotten 2 minus 2 cosine x equals 2 plus 2 cosine x. Subtract 2 on both sides. You have negative 2 cosine x equals 2 cosine x. Add 2 cosine x on both sides. Divide by 4. You still get the same answer. Yeah. Okay.
You can also divide by 2. Right.
Yeah, you can divide by 2 everywhere. Yeah. Cool, cool. This is our last page. Wonderful. That's good. Let's see. Yeah, so I think we'll have enough time to do at least example 7. All right, so we talked about a lot of stuff today, but we have almost 2 full class periods coming up where we're just gonna be practicing. So now that we've introduced it, plant the seeds, you can work on some homework. Like after this, I'm just trying to like preface what it's gonna look like. So I'm gonna introduce these to you, and then we're really gonna practice the next 2 class periods. So don't freak out, being like, when do I use which, where, what, when, who, what. We're gonna figure that out. All right, so often in calculus, it's necessary to work with functions, which are the product of 2 trig functions. Literally, you have 2 trig functions being multiplied, cosine 2x, sine 5x. This is 100% true. To simplify those functions, we need a product to sum. So notice, you're taking 2 trig functions, multiplying them, which is a product. So if we want to rewrite it as a sum or difference, that's exactly the keywords I'm going to use. Rewrite as a sum or difference. You're taking it from a product to a sum. So you're taking 2 things that are multiplied and rewriting it as a bunch of things added. So let's rewrite cosine 6x and cosine 3x. So how do you recognize what to use? I am multiplying 2 cosines together. Multiplying 2 cosines, I'm just going to be plugging into this. So 6x is going to be the alpha I'm going to use. 3x is going to be the beta, which is just the second angle I will use. All right, so I'm using, and like really, when do you use this? You want to use this when multiple trig functions have different angles, especially angles that you like don't know. So I can rewrite this as cosine 6x cosine 3x is going to equal 1/2. I'm just following the identity, which is why I told you have your identity sheet out. I don't know this. I'll memorize it. Why? I'm giving you the sheet. We're just going to pull it up. What you have to know is what to use when. All right, so 1/2 cosine of alpha minus beta 6x minus 3x plus cosine of 6x plus 3x. So I can rewrite this as 1/2 of cosine 3x plus cosine 9x. But then we have to distribute the half. So it's just going to be 1/2 cosine of 3x plus 1/2 cosine of 9x. Yes?
So what's the difference between this one, like this is gonna apply to sum and the sum identity?
So the sum identity is you're adding two angles together. So
Like, how would I know? Just
so if you have a problem that says like what is cosine of 15 plus 60? Then so you're adding two angles together versus taking cosine 50 times cosine 60. So if you're multiplying the two trig functions versus adding the angles. Yeah. Yes.
Angles, right?
All over 2, yeah. That's fine. That's the same thing.
I think that's the answer.
Yep.
division is the how do you know? No.
I mean, there's nothing else I can do because it's in terms of x. Yeah. Okay. So do I want to do this one now? Yeah, we still have 5 more minutes. We can do this. All right. So the difference between these two, if you're multiplying two trig functions together versus adding them. If you are multiplying them, you're going to use the product to sum. If you're adding two trig functions, you're going to use the sum to product. It's just going the opposite ways. All right, so the sum of two trig functions can be condensed using sum to product identities. So we want to find the exact value of cosine 255 plus cosine 195. All right, so here I have a cosine plus a cosine. Cosine plus a cosine. This is going to be the one I use.
At least it's different than the sum identity.
The sum identity. So I'm not taking cosine of 255 plus 195. I'm taking cosine 255 plus cosine of 195. Am I adding the angles or am I adding the two trig functions of those angles? Yeah. All right. So this is my alpha. This is my beta. I'm just going to plug into the equation. So I have 2 times cosine of 255 plus 195 all over 2 times cosine of 255 minus 195 over 2.
Question, could the 2 just cross out the 2?
No, because the 2 is inside of cosine. It's cosine of all this stuff. So you can't just cross out things inside. When you're taking cosine of it, it doesn't cross out from the inside.
Have you ever calculated this stuff?
Well, ask that question in 10 seconds once we simplify this. Because the answer is you don't need it. Okay. So I have 2 times cosine 255 plus 195. 450. 450 over 2 times cosine of 60 over 2. So wait, that's just 2 times cosine of 225, which is one of your reference angles, cosine of 30. So you don't need a calculator for this. I mean, if you can't do, what's 255 minus 200? 55. So if you take 255 minus 195, it would be 5 more, which is 60. What is 255 plus 200? 455, which means if you're adding only 195, it would be 5 less, which is 450. Okay. So this is equal to 2. What is cosine of 225? So 225, let's see, 0, 90, 180, 270. So we're in the third quadrant. Yeah? You see how I did that? Okay, ready? 0, 90, 180, and then it goes 270. So I'm somewhere in the bottom third quadrant. 225 is a 45-degree reference angle. So what will it be? I'm in the third quadrant. Both sine and cosine are negative. Negative root 2 over 2. And cosine 30? You know cosine 30?
Red. No, 1/2.
Root 3 over 2. Alright, simplify this out. We have negative 2 root 6 over, it's positive because we're in the first quadrant. 30 degrees in the first quadrant. So multiply 2 times negative root 2 times 3 is negative 2 root 6. All over 4, so it's just going to be negative root 6 all over 2. Beautiful. Cool. So this is where we'll end for today. Next class, we'll do the last problem, and then make sure you have your practice test and study guide. We'll go through the practice test first, identify what we struggle with, and then we'll spend the rest of next class and the class after that working on specific problems from the study guide.